Hello, the purpose of this lesson is to provide an overview of the Chapter 5 lecture in probability and statistics. And as usual, we will be starting off our lecture with another set of vocabulary words that we will be using throughout the rest of the semester. So let's talk about the concept of a random variable. A random variable is a variable typically represented by x that has a single numerical value determined by chance for each outcome of a procedure. A probability distribution is a description that gives the probability for each value of the random variable. It is often expressed in the format of a table, a formula, or a graph, and we will be looking at all different types this evening. Some more definitions. A discrete random variable has a collection of values that is finite or countable. A continuous random variable has infinitely many values, and the collection of values is not countable. We already have a fundamental understanding of the difference between discrete and continuous, except in this case, we will be applying those definitions to random variables. So let's start off with looking at what is called a probability distribution. Not every table or every formula or every graph is going to be depicting a probability distribution. We actually have to check and make sure that three requirements are met. We do not typically test on these requirements. We work under the assumption that the requirements are met, or we can validate that rather easily. The first requirement is we have to have a numerical random variable x, and its values are associated with corresponding probabilities. So if you look at the table at the bottom of page 1, we have a random variable x, and x can take on the value 0, 1, and 2. And the probability of 0 occurring is 0.25, and the probability of 1 occurring is 0.50, and the probability of 2 occurring is 0.25. And this is the probability distribution for the number of girls in 2 births. So the probability of having 2 girls in 2 births is 1/4, right? 0.25. The probability of having 1 girl, if you have 2 children, is 1/2. And the probability that you would have no girls, right? X is 0 would be 0.25 or 1/4. So the first requirement is actually met. We do have a numerical random variable x, and its values are associated with corresponding probabilities. We just verified that. The second requirement is that the sum, this Greek symbol here, sigma, stands for summation, and the sum of the probabilities must always total 1. Well, if we add up 1/4, 1/2, and 1/4, we will get a total of 1. So the second requirement is met. The third requirement simply says that each probability must be between 0 and 1 inclusive. And all of our probabilities here are between 0 and 1. So this does give us a probability distribution. And here's the graph to the right that depicts that probability distribution. Example 2. Review the table below to determine whether the three probabilities, distribution requirements are met. Let's check and see. First of all, we have to have a random variable that is numerical. Well, the responses on this survey are random. They could be yes, no, or don't know. And they do have corresponding probabilities. But the problem is x is not taking on numerical values. Yes, no, and don't know are not numerical values. We cannot do any mathematics with those. So this is not a probability distribution. Example 3. Does P of x is equal to x divided by 3, where x can be 0, 1, or 2? Does that determine a probability distribution? Let's go back and check the three requirements. Do we have a numerical random variable x? Yes, x can take on the values 0, 1, or 2. And would the sum of the probabilities be 1? Well, the probability of 0 occurring would be 0 over 3, which is 0. And the probability of 1 occurring would be 1 over 3, which is 1/3. And then the probability of 2 occurring would be 2 out of 3, which is 2/3. And if you add up 0 plus 1/3 plus 2/3, you would get 3/3, which is 1. So the sum of the probabilities is 1. And finally, we must check to verify that each probability is between 0 and 1 inclusive. Well, 0 is between 0 and 1 inclusive. 1/3 is between 0 and 1, and 2/3 is between 0 and 1. So this does represent a probability distribution. Now, if you have a probability distribution, you can calculate its mean, its variance, and standard deviation. And here are some formulas. In fact, there are 4 of them. The first formula, 5.1, tells us how to find the average of a probability distribution. Notice we have this Greek symbol here. It says that we are going to sum something. Well, what are we going to be summing? We're going to be summing products. Products being x times the probability of x. So we're going to sum each x value multiplied by its probability. So we're going to multiply 0 times its probability plus 1 times its probability plus 2 times its probability. And when we add those up, we will figure out that the average for this probability distribution is 5/3. Again, please go back and check my mathematics because sometimes I do get in a hurry. So that's how you would find the average for a probability distribution. It's just the sum of the products of each x value times the corresponding probability. If you want to find the variance of a probability distribution, you're going to be taking the sum, but it's a little more complicated. You're going to have to take each x value, and you're going to subtract from each x value the average, which we just figured out is 5/3. And then we will square that result and multiply that by the probability of that x value. So that is the formula for the variance. It's also the one that we will not be using in class. We will be using formula 5.3. They actually give us 2 formulas to find variance. This one is easier to calculate. This one says that you take the sum of each x value squared times the corresponding probability, and then after you take that sum, you simply subtract off the mean squared. So what are the 3 x values? Well, the x values are 0, 1, and 2. We're still in example 3, right? So if x is 0, I would take 0 squared times the probability of 0, which is 0 over 3. And since it's a summation, I have to add, and I'm going to take the next x value and square it and multiply by its probability, which is 1/3. So 1 squared times 1/3. Then I'm going to sum and take the last x value, which is 2. That would give me 2 squared times 2/3. I'm going to then add up everything that's in this bracket. All of this has to be totaled. Once I get that total, I then subtract the average squared. And we calculated in the first part up here that the average is 5/3. So, of course, 0 squared is 0, and 0 times 0 over 3 would be 0. And 1 squared is 1, and 1 times 1/3 would be 1/3. Then we have 2 squared, which is 4, and then 4 times 2 is 8. That would give us 8/3. And then finally, we would subtract the mean squared. And 5 over 3 squared is going to be 25 over 9 because 5 squared is 25 and 3 squared is 9. Now, when I add the 1/3 and the 8/3 together, I get 3. But remember, we have to subtract off that mean squared, which is 25 over 9. We have to get a common denominator in order to subtract fractions. So I'm going to change 3 to 27 over 9, and then 27 minus 25 is 2, so the variance is 2/9. If you want to find the standard deviation, just take the square root of your calculation for variance. So the square root of 2/9 is equal to about 0.4714. So that's just an application of the formulas for finding the mean, the variance, and the standard deviation for a probability distribution. Example 4. Example 4 says, use the table below to find the mean, variance, and standard deviation of the probability distribution. If you look at Formula 5.1, remember it says that if you want to find the mean of a probability distribution, you just take the sum of each x value times its corresponding probability. So the x values here are 0, 1, and 2. These are the probabilities. So I'm going to take 0 times its probability, plus 1 times its probability, plus 2 times its probability, and I get 1. So the average number of girls in 2 births would be 1. Okay, so if you have a group of people who have 2 children, for whatever reason, let's say you start a convention and the only people allowed to attend must have 2 children. On average, they will have 1 girl per family. The variance is calculated by taking each x value and take each x value and subtract the average, square it, multiply by the probability. And so that's going to be 0 minus 1 squared times 0.25. Then we have 1 minus 1 squared times 0.50. And then we have 2 minus 1 squared times 0.25. And we get the variance is actually equal to 0.5. Okay, so it appears that on that one I used the other formula for variance. So if you want to go back and find the variance using the preferred formula, you can do it that way as well. So figure out which formula for variance you prefer. To me, the one that I just used is not the easier one. To me, the easier one is going to be formula 5.3. So do that as an independent exercise. Go back and find the variance using formula 5.3 and see if you do not get 0.5. And if the variance is 0.5, what would the standard deviation be? Well, you would just take the square root of 0.5, and that would be approximately 0.7071. Now we're going to talk about a concept called the binomial probability distribution. It is a probability distribution, but it's a special case, and it's actually one of my favorite, and we will deal with it quite frequently on the next test. A binomial probability distribution results from a procedure that meets the following requirements, and you will have to know the requirements for a binomial probability distribution. First, you must have a fixed number of trials, denoted by n. The trials must be independent. Each outcome must fall into one of 2 categories. That would be, for example, success or fail, hit or miss, and so forth. Finally, the probability of success, P, is fixed throughout all trials. And then we use Q to denote the probability of failure. Let's look at an example here. Example 5, Twitter. When an adult is randomly selected, with replacement, there is a 0.85 probability that the person knows what Twitter is. Suppose we want to find the probability that exactly 3 of 5 random adults know what Twitter is. Let's go back and put it into context. Basically, 85% of adults know what Twitter is. So if you were to go out and randomly choose 5 adults and survey them and say, do you know what Twitter is? What's the probability that exactly 3 would know what Twitter is? Well, part A says, does this even represent a binomial distribution? Let's go back and look at the requirements. Do we have a fixed number of trials in? Yes, we do have a fixed number of trials. We're going to ask 5 people if they know what Twitter is. So each time you ask is considered to be a trial. Are the trials independent? Well, since we are doing it with replacement, we do have independence. We talked about that in an earlier lecture. So we have independence. Do we have two outcomes? Yes, either they know what Twitter is or they don't. There are only two possible answers. And then do we have a fixed probability of success P? Yes, because research has shown that 85% of adults know what Twitter is. So every time we ask an adult if they know what Twitter is, there's an 85% probability that they will say yes. So this would be a binomial probability distribution. If this is a binomial probability distribution, identify the number of trials N, the number of successes X, and the probability of success P. Okay, so we have said that the number of trials is 5, so N would be 5. The number of successes we're looking for is 3. We want to know the probability of 3 people saying yes, that they do know what Twitter is. And then we know that the probability of success, I believe we said that's 0.85. And the probability of failure then would be 1 minus 0.85. That would be 0.15. So now that we know this, let's figure out the probability. Well, we could do this by hand, and it's somewhat lengthy, but we're going to use the TI-84 calculator, and we're going to use the binomial PDF function on the calculator. So here's what we're going to do. You're going to go to second vars, second distribution, and you're going to select binomial PDF. Make sure that you select PDF, not CDF. And then you simply follow the syntax here. You're going to put in N, the number of trials, which is 5, followed by P, the probability of success. And then you're going to plug in Q, the probability of failure. So it would be binomial PDF. And for this particular problem, we would have 0.85 for the probability of success. And then we would put 3 for the probability that exactly 3 would know what Twitter is. So once you run that, you should get 0.138. So let's try this again using example 6, devil of a problem. Based on a recent Harris poll, 60% of adults believe in the devil. So again, we're going to choose 5 adults, and we're going to try to figure out the probability that exactly 3 of the 5 adults believe in the devil. Well, this would be a binomial probability distribution. It meets the 4 requirements. And we would simply do second vars, binomial PDF. We would enter 5 for the number of trials. And since we have a 60% probability that they believe in the devil, we will put 0.6. And then we will put 3 because we are trying to figure out the probability that exactly 3 of the 5 adults believe in the devil, and that would be 0.3456. So putting it in context, if you were to randomly choose 5 adults and ask them if they believe in the devil, the probability that exactly 3 of those adults would say yes is about 34.56%. Part B says, what is the probability that the number of adults who believe in the devil is at least 2? Well, if at least 2 believe in the devil, then that means 2, 3, 4, or 5 would answer yes. We could do it that way, which is rather lengthy. I'm going to back it out this way. I'm going to use binomial CDF. CDF is going to give me the probability that 0 or 1 would answer yes. And the probability that 0 or 1 would answer yes is 0.08704. So the probability that at least 2 would answer yes would be 1 minus 0.08704, which is 0.91296. Think about it this way. The probability that at least 2 adults answer yes is 1 minus the probability that 0 or 1 answer yes. I know that's difficult for a lot of students at the beginning, but think about it, and hopefully it will become clear as you continue to work with these types of problems. I would also recommend at this point, if you are struggling to understand the difference between binomial CDF and binomial PDF, just go to YouTube and do some searches, and there should be plenty of videos online that will give you examples of how to use those two functions on your calculator. Okay, so that takes care of this part. Parameters for binomial distributions. If you have a binomial distribution, the formulas for finding the mean, the variance, and the standard deviation are a lot easier to deal with. For example, if you want to find the average for a binomial distribution, it's n times p. The variance is n times p times q, and the standard deviation is the square root of n times p times q. Let's go back to the devil problem here. Based on a recent Harris poll, 60% of adults believe in the devil. Suppose we randomly select 5 adults. Find the average. Well, on average, how many adults would say that they believe in the devil? Well, the average is just n times the probability. That's going to be 5 times 0.6, which is 3. So on average, if you ask 5 adults if they believe in the devil, the average would be 3. 3 people would say yes on average. Part B, what is the variance of the binomial distribution? Well, the variance is going to be n times p times q. Remember, q is the opposite of p. It's going to be 1 minus p, the p-value. So 1 minus 0.6 is 0.4. So multiply those together and you get 1.2. And of course, if you take the square root of 1.2, that would give you 1.095. That would be your variance. I'm sorry, that would be your standard deviation. And finally, on part D, since usual values fall within 2 standard deviations of the mean, identify the minimum and maximum number of usual values. Remember that values are considered usual if they are within 2 standard deviations of the mean in both directions. So take your average, which is 3, and then add 2 standard deviations, and then take the average and subtract 2 standard deviations. So that's going to be 3 plus 2 times 1.095. That's going to be 3 plus 2 standard deviations, and that would give you the 5.19, which would be your maximum. And if you do 3 minus 2 times 1.095, that's 3 minus 2 standard deviations, you would get 0.81. What does that mean? That means that if more than 5, up to 5, say they believe in the devil, that would be considered normal. That would be usual. It would not be an uncommon thing for 5 out of 5 people to say that they believe in the devil. That's on the high end. On the low end, it says that if less than 0.81 say that they believe in the devil, that would be unusual. So if 0 people said they don't believe in the devil, that would be unusual. So try to become familiar with the concept of adding and subtracting 2 standard deviations from the mean, and that will give you a typical range of, quote, normal responses or acceptable responses. So if you were to survey 5 people and 0 people believe in the devil, something is off there. Maybe you did not randomize your samples. So this pretty much concludes the lecture for 5 here, and hopefully we will see you back soon. Hope it helped. Thank you.